All right, today we're going to start chapter 4, and chapter 4 is going to start with divisibility. And the first thing I want to talk about is what we mean by the word divide. So if A and B are whole numbers, we say that B divides A, and I want you to notice how that is written. Okay? It is not written like B is the numerator with the denominator of A. That's not what that says, right? It says B divides A. So this vertical bar means divides. Okay? That's really important because it's a really funny notation compared to our fraction notation. B divides A if and only if there's a unique whole number Q such that A is B times Q. If B divides A, B is a factor of A or a divisor of A, and A is a multiple of B. So let me use numbers so you can talk about what this looks like, okay? So 4 divides 20, right? Yeah, it does, because I can write down 20 and I can divide it by 4. Does that make sense? So 4 divides 20, so we would write this like this. And you can read it just from right to left, and from left to right, just like you normally read, 4 divides 20. And what it means is that 4, another way of saying that is 4 is a factor of 20. And it is, right? 4 is a factor of 20. We can say 4 is a divisor of 20. Is a divisor of means divides. So it is a divisor of 20. Or we could say 20 is a multiple of 4. And all of this works because if you try to divide 20 by 4, what do you get? 5 with no remainder. Right? The no remainder part is what's making this work. It goes in evenly. Okay? So this ABQ business up here, if you're taking a look at this, we're saying that this works because 20 is equal to 4 times 5. 5 is that Q that's referred to it there. There is a number that when you multiply it by 4, you get back 20. Okay? Now, the first theorem says for any whole numbers A and B, if D divides A, okay, so D is one of these divisors, it's one of these factors of A, and N is any whole number, then D divides N times A. So let me give you an example, and we'll do the example with the same number up here. You know that 4 divides 20, right? Well, that means that 4 is also going to divide 20 times 3, or 20 times 4, or 20 times 15. 4 will divide 20 times any other whole number because 4 divides 20. So it's automatically going to divide 20 times something. That's all that theorem says. If a number divides something, it's going to divide any multiple of that thing as well. Okay? So that's first theorem. Theorem 4.2 has multiple facts to it, so I'm going to write them all in. So the first issue is that we're dealing with numbers, whole numbers A, B, and D. All right, so here's the first one. If D divides A and D divides B, then D divides A plus B. So let's think of the numbers 4 and 20 again. If 4 divides 20 and 4 divides 8, then that means 4 divides 28. You just add the two values together. If it divides them individually, it divides their sum. That's what that one says. Okay? All right, let's try another one. If D divides A and D does not divide B, then D does not divide A plus B. It almost looks like the first one, right? So again, if 4 divides 20, and 4 does not divide 7, then 4 does not divide 27. Does it? That's what that's saying. Okay, we're going to mirror this next one like we did on part A. If D divides A and D divides B, then D divides A minus B. If it works for addition, it looks like it works for subtraction, right? So let's do the same thing again. If 4 divides 20, and 4 divides 8, and 4 divides 20 minus 8. What's 21 say? 12. Does 4 divide 12? Yes. So I can subtract the two values and it will work. So let's do a mirror image of part B for what part C is doing. So if D divides A and D does not divide B, oh, we need one more condition. I'll put this in a minute. Then D does not divide A minus B. I'm going to use the 20 and 7 a minute ago. Okay? So 4 divides 20. 4 does not divide 7. So 4 is not going to divide 20 minus 7. So what's 20 minus 7? 13. So 4 divide 13? No. Okay? Now, in doing all of this, I was actually doing this actual other feature. This was actually only because we're talking about A being bigger than B. Because we're still working with whole numbers here. So I want to make sure that I did 20 minus 7 and not 7 minus 20. We're just keeping them as whole numbers. That's all that condition is doing for us. It's not really affecting anything. All right, and then the last one, if D does not divide A, but D does divide B, then D does not divide A minus B. Still, A is greater than or equal to B. So it's saying really I can make that not equal to, that not division part rather, at the first value or on the second value in this whole. Right? So instead of using 20, let's say to 21. 4 does not divide 21, right? 4 does divide 8. But 21 minus 8 is what? 13. 4 still doesn't divide 13, right? So I can sort of fail the very first piece and the second piece and it's still going to all fall apart.
Why did you make that first subtraction but not the addition? Is there any reason?
Because with addition, that we don't have this extra condition of A greater than B, so we could flip this order around because of the commutative property anyway.
I mean, the D not dividing.
You mean up here? I know. Yeah, because these actually are, well, for A and B, they're commutative. So A plus B is equal to B plus A, but I couldn't switch that around down here without preserving the whole number property. That's the only reason. So this extra one thrown in here at the end just says, hey, it works the other way, just like it would have for addition, even though it's not commutative. Okay, we're going to talk about some divisibility tests. You've probably seen or thought about these before. So when I do this in contemporary math, or have done this in contemporary math before, I usually will do what I'm doing here. So again, you've seen some of this before, but maybe you haven't thought about it this way. So let's take a look. A divisibility test for 2. If I give you a number, how can you decide if that number is divisible by 2? If it's even. What does it mean to be even? When you look at a number, how do you know that that number is even? Say that louder for me, Beth. Right. This is if it ends in 0, 2, 4, 6, or 8. You could also say if the last digit's even, specifically, right? The whole number is even if you just look at the last digit's even. Agreed? Okay, it's all about the very last digits, what it ends in. How do you decide if a number is divisible by 5? If it ends in a 0, 5. And how do you decide if a number is divisible by 10? Yeah, if it ends in 0. You guys know those, right? Now, you may not know some of the other ones. Anybody know the divisibility test for divisibility by 4?
All the numbers add up to a number that's...
There is a test about that, but it's not for 4.
Okay.
So we're going to get to that one later. It's not for this one. Well, it certainly would have to be even, right? But that may or may not be enough. Agreed? Like for instance, 20 is even and it's divisible by 4, but 22 is even and it's not divisible by 4, right? So how do we decide? Well, we actually decide by using those last 2 digits. So the last 2 two digits, not added. We're not talking about adding them together. We're just talking about looking at only the last two digits as its own independent number. So whatever occurs in the tens place and the ones place, if you take that as the number you're looking at, and it's divisible by 4, then the whole thing's divisible by 4. Yes, I will. Let me finish writing this. The last two digits are divisible by 4. So let me give you, Carrington, both an example and a non-example, okay? So let's say we have the number, let's do 414. And we'll do 416. So these are both 3-digit numbers, and this rule says what I should do is I should look at the last two digits. Is 14 divisible by 4? No. So neither is 414. And it's not divisible by 4 because 14 isn't divisible by 4. But then the 416, I look at the 16, is the 16 divisible by 4? No. So this one is divisible by 4 because 16 is divisible by 4. Okay, before I get to theorem 4.7, let me make a comment about what you just saw me do. So you saw me give me an example, and I will tell you that in the directions in your book, I don't think it's ever going to ask you to justify your answer for why it works or doesn't work, it is divisible or it's not. What do you think I'm going to have to do on a test? Yeah, you're going to have to explain it. So it would be wise, although I won't take off points if you don't do it now, it'd be wise to start getting in the habit of doing that even on your homework. Because that way when you look back at it, you know what you did to make the decision and can study from that. Yes?
When you say explain it, do you think it's just what you do?
Yep, that kind of language is sufficient. You got it. Okay, so think with me on this. How did we decide if a number was divisible by 2? It was even, and we decided it was even by looking at the last digit. When we did the value 4, we looked at the last two digits. So what do you think is going to happen for divisibility by 8? Close. 3. It's just 3. Yeah. It has to do with powers, right? So 2 to the third is 8. That's 3. The last 3 digits is what we need. So I kind of wrote into my space, but a number, whole number is divisible by 8 if and only if the last 3 digits are divisible by 8. Okay, so we can do an example as well on this. Do you want to see one? Okay, so it's going to look a little bit contrived because I don't know multiples of 8 all that high. I can do 4 a little bit better. But let's say that I had, and I'm testing, does 8 divide, I have no idea if this is going to work, so let's see. So somebody tell me, grab your calculator. What do we need to test actually though? Just need to look at the 246. So take 246, it's even, so it stands a shot, right? I mean, we take a chance, it's even. Is it going to work? I think the answer is going to be no, because this isn't even divisible by 4. So this is a no. How do I know it's not divisible by 4? 46 is not divisible by 4, right? If it's not divisible by 4, is it going to be divisible by 8? No, you can't make that work, though. That wouldn't work. Yes, Beth?
Can you also use that since, like, if you have 416, since it's divisible by 2 and 4, it's also divisible by 8?
That's a really good question. So the answer is going to be no in general, but in some cases the answer is going to be yes. The reason the answer is going to be no for the one that you gave the example of is because 2 and 4 have a factor in common of 2. If you had used other numbers, it would work, and you're going to see that happen on the next slide. Okay? All right. Oh, not the next slide. Okay, 2 slides in. My bad. How about 3? This one's the one that Lydia wanted to talk about. Does anybody remember the divisibility for 3? Yeah, that's the one you're remembering, Lydia. Yeah. This one I remember encountering in high school when a teacher was like a calculus class or whatever, which had nothing to do with calculus. But she mentioned it and I was like, man, that's super cool because it made things so much easier. The way you can decide if a number is divisible by 3 is you add up all the digits, just sum them, just add them quickly in your head. And if that value, after you add them up, is divisible by 3, then the original number was divisible by 3. So, if and only if the sum of the digits is divisible by 3. So let's do an example. All right, let's go with that one. All right, so if we were to add the digits together, 4 plus 6 plus 2 plus 8 plus 1, what do you get?
21.
21. Is 21 divisible by 3? Yes, so since 21 is divisible by 3, so will 46,281 be divisible by 3. And you didn't need a calculator for that, did you? No, you can do it pretty quick. So now, this is not enough justification. So if I ask you to explain something and you write out numbers like this for me, it's not going to fly. Okay, I had some architects think about that last semester. It wasn't in this class, it's in contemporary math, but explain these words, and you guys know it now, right? Yeah, you guys lost a lot of points for that. But you've got to get it back. But explain these used words. So you can justify by writing that to begin with, and then you can say, because 21 is divisible by 3, 46,281 is also. Okay, so just the words that say what you're actually deciding now. This is divisible by 3. Yes?
When you're explaining that, can you say because 3 divides 21,
Yes.
3 also divides?
That's exactly the same statement. Back on that very first slide where I used the words factor and multiple and divisor, they can be used interchangeably. So yes, you can do that. Any guesses what might be for 9? Easier than that. It's actually the same test as 3. It's just that at the end, you have to test whether the sum is divisible by 9. Okay, so if I use the same example, is this number going to be divisible by 9? And the answer is no, because 21 is not divisible by 9. Are you with me? Everybody okay? So, whole number is divisible by 9 if and only if the sum of the digits is divisible by 9. And we can do the same example. It's just going to have a different answer. So if I did 46,281 and I added them together and I got 21, the answer is that it's not divisible by 9 because 21 is not divisible by 9. Now, just notationally, let me draw your attention to something. It worked for 3, right? So it would be appropriate to write 3 divides 46,281. Remember, that's not a fraction. It's read 3 divides this, and it does, right? But if we wanted to talk about 9, what symbol do you suppose would go in between there? Yeah, you draw the line as though it divides, but you know it does not divide. So just how we've written other things when we've said is not something, like is not an element of, is not equal to, we just draw that slash through it for does not divide. Okay, Carson, good? Okay, I think there's another one. This is the one I was telling Beth about. Okay, I lied. The second one on the slide is the one I was telling you about that. Not the first one. All right, the first is a little unusual. This is divisibility by 11. Okay, so divisibility by 11. A whole number is divisible, I can't talk, is divisible by 11 if and only if the sum of the even digits I'm going to write it a little differently than your book. Minus the sum of the odd digits. And I don't mean the digits that are even or the digits that are odd. I mean the places where there's like I'll just see what I mean. Okay? Of the odd digits. Is divisible by 11. Together. So we're going to have lots of numbers. We're going to have 4, 6, 3, 2, 9, 8, 4, 1, 0, 3, 7. I don't know. First makes it up. It'll work just as well. All right. So let me put some commas in here for how long I've got a number. Okay. So what we're going to do is I'm going to go through and I'm going to circle every other number. Did I screw one up? Oh, I did. Thank you, Lexi. What was this number? 7? 2. All right. I'm just going to circle every other digit. It doesn't really matter which one I start with or end with. So I'm just going to circle every other one. Okay? I'm going to add up all the ones I circled. And then as a separate addition, I'm going to add up all the ones I didn't. Okay, so I'm adding up every other digit is what I'm doing. All right, so what's 4 plus 3? Plus 9? 16 plus 4, 20 plus 0, 20 plus 7, 27. So the ones that are in the circle add up to 27, right? So just so that I can be clear, we'll underline the next ones. All right, the underlined ones. I've got 6 plus 2 is 8, plus 8 is, plus 1 is, plus 3 is 20. Right? 20. And then what I do is I subtract those numbers. 27 minus 20. So what's 27 minus 20? Is 7 divisible by 11? No. So then this original long ugly number is not either. There's not a really good way to write what I just did, but the process is pretty easy, right? You add a bunch of stuff, subtract some stuff, and you look at it's divisible by 11. Make sense? Okay. So this will not be divisible. Pretend that says divisible by 11 because 7 is not divisible by 11. That's how I made the decision. I looked at that last number 7. All right, here's my divisibility test for 6, the one that I keep telling you that I was about to get to. All right, a number is divisible by 6 if it's divisible by 2 and 3. Because what's 2 times 3? 6. Now, Beth's question was, did that work if I could have done it with 2 and 4? And the answer was no, because 2 and 4 actually have a factor of 2 in common. So this divisibility test for 6 will work with any numbers that are what we call relatively prime. That means any numbers that don't have factors in common. So I could use 3 and 5. I could use 3 and 7. I could use 3 and 8, even though 8 is not prime, I could use 8 because 3 and 8 have nothing in common. Okay, so this rule that I'm doing for number 6 here, this divisibility test for 6, actually works in general as long as the 2 factors you're looking at don't have anything in common with one another. So, if it is divisible by 2 and 3. Somebody give me an example. Make up something.
36.
Oh, something bigger. Give me a 4-digit number. 200, what would you end up with? 36. Okay, so how do I check if something's even? I look at the last digit. Is this even? Yes, so we know it's divisible by 2, right? Is it divisible by 6? What else do we still test? We test with 3. So how do I test if it's divisible by 3? Add them up. What do you get if I add those numbers up? I get 15. Is 15 divisible by 3? Yes. So this number then will be divisible by 3. I tested if it was even. I tested if it was divisible by 3. So then it's divisible by 6. Okay? So let's write down this information. So it's divisible by 6. That's a 6. Because, number 1, it's even. So it divides by 2. And then number 2, the sum of the digits is 15, and 15 divides by 3. So 42, 36, whole 2. Those are the 2 things you have to check. And then once you've checked that they both work, you automatically get their divisible by 6. Alright, you guys ready to do one now? Just specific, that's not specifically for anyone in particular, but do them all. Okay. Sure. We've got the number 24,015, and we're going to decide it's divisible by 2, 3, 4, 5, 6, 8, 9, 10, and 11 using the divisibility test. So you have to justify your answer in any step, yes or no, and why. All right, so we're going to start with 2. Is it divisible by 2? No. Why? Because 5, specifically the number at the end, right, is not even. How about the number 3? It does work. How come? It's not the last 2 digits. Okay, because if I add 2 plus 4, oops, that's not a 4. Let's try that again. 2 plus 4 plus 0 plus 1 plus 5. I get 12. And 12 divides by 3. So the original number will 2, right? How about 4? The next one's 4. Will this divide by 4? No. For a couple of reasons. Somebody give me one of them. Yeah, if it's odd, there's no way it's going to divide by anything even. So it's certainly not going to divide by 4. But if we go back to the actual test, what does the test say? The last 2. So because 15 does not divide by 4. 15 does not divide by 4, then the whole number won't. How about 5? Yes, why? Because the last digit is 5. 6? No, why not? No, because it's not divisible by 2. 8. No, why not? Right, so let's use the actual rule because we need to be in the practice of doing that. What would I actually test if this were even at the end? 0, 1, 5. So this is not going to work because 0, 1, 5 does not divide by 8, right? 16 would, 0, 1, 6 would, 0, 1, 5 would not. 9 is the next one. Madison says no. Why not, Madison? Right, no, because the sum of digits was, what was it? 12 doesn't divide by 9. A couple more left. The number 10. No. Why not? No, because it doesn't end in 0. And then 11 requires us to do a little bit of work, but the number's not very long. So 2, 4, 0, 1, and 5. What do I do? Okay, so I circle those and I get 7. And then 4 and 1 is 5. And then what do I do? 7 minus 5 is 2. Is 2 divisible by 11? No. So then the original number, 24,015, is not accurate. So this is no. Because 2, which this work shows where that 2 just came from, so you've got to justify that 2 in this process. 2 does not divide by 11. If you've shown the work before that, no. So if you show me that this work is worked out before I can see where that 2 came from, you're okay. If you wanted to call it something, that's where you run into problems. The language and how we came up with it had a lot of details, and it's a little awkward. That's why I say, if you show me the work of where the 2 came from, I'm okay with it. Okay. All right, next question. It's only question number 2? You gotta be kidding me. Classify each of the following as true or false. Okay, so these look very similar to one another, and in fact, they go back to something we've already talked about. If a number is divisible by 6, then it is divisible by 2 and 3. Yes, that is true. That is a true statement. And then the next one says, if a number is divisible by 2 and 3, then it is divisible by 6. That's actually also true. And let me go back to the rule to show you why it's true, okay? What about this rule tells me that this is going to work both for part A and part B of that problem? You know what it is? Say that louder, Brendan. Okay. Well, what part of that is the key part in making this work? The if and only if. If and only if means that I can read this direction going front ways or going back ways. I can make the first part the if and the second part the then, or I can make the second part the if and the first part the then. And this worked on all of these divisibility rules. They are interchangeable. So this problem that we just did and put true on is exactly those 2 statements separated out and written without the words if and only if between them. So it really does work in both directions. Okay? Now, part C and D are a little different because I don't exactly have divisibility rules like what Beth's question was, right? Is can I use 2 and 4 to make the decision about 8? And I actually told you that you couldn't, didn't I? Okay, so let's actually think about these. One of them is true and the other one's not. C is false and D is true. So here's the catch. When we say false, we have to be able to provide an example that shows why. So your example actually will work. Yeah. Okay. Sure, we can use that. Works as well as anything else. We'll write a couple others over too if you don't like 4. Is 4 divisible by 2? Yes. Is 4 divisible by 4? Is 4 divisible by 8? No. Somebody create another one for me. Okay, 412. Or you could just use 12, right? Sure could. All right, 412. We can really just look at the 12 at the end. Is 12 divisible by 4? Yes. Is 412 divisible by 4 then? Is 412 divisible by 2? Yes. Is it all divisible by 8? No, that one won't be divisible by 8. However, part D is, it works. If a number is divisible by 8, if and only if it's divisible by 2 and 4. Actually, I wrote it wrong. If this said if, it would be true. Okay, so if I mark that part out, it's true. But because it says if and only if, what does that mean? It has to go both ways, and if I switch it, it looks just like C, doesn't it? Okay, so this actually is going to be false because I should have had this included. That is included. It's not supposed to be marked out. So if it is not marked out, then the answer would be false because it's what Madison just said. If I switch it, this looks just like part C, and we already said part C was false. Make sense? Yeah. All right. Okay. Example 3 says, and we'll do this one and we'll pause for today. Answer each of the following without actually performing the division. Explain how you did it in each case. Is 34,015, we don't have divisibility test of 17, so you think something different. Is 34,015 divisible by 17? No. Okay. Heather, you got to tell me why.
Well, 34 is divisible by 17, so you know there wouldn't be any extra numbers down the bottom after you divide it. That doesn't really make a lot of sense.
Sure it does. So if 34 goes in evenly, I don't have any remainder, right?
Right, yeah.
Yeah, there's no remainder. And then what?
But it doesn't divide into 50.
Yeah, but then 15 doesn't work. Does that make sense to everybody? Okay, part B. Is 34,051 divisible by 17? Yes. Why?
Well, I just said 34 is divisible by 17. 51 remainder also is.
15 is also, isn't it? What's 51 divided by 17? It's 3. Yeah. Okay. C is almost identical, agreed? To part A, actually. So is 19,031 divisible by 19? No. Why not? So 19 is divisible by 19, but what? But 31 isn't. All right, last two. Is 2 times 3 times 5 times 7 divisible by 5? You do not need to multiply the problem out to find this answer, guys. Is it divisible by 5? Yes, it is. It is. How do you know?
There's a 5 in there.
There's a 5 in there.
Oh my goodness.
You remember what divisible by means? Being divisible by a number means it has that number as a factor. Is there a factor of 5 in that number? Yeah, I mean you can see it, right? It's got a factor of 5, so it's going to divide by 5, no question. Okay, so, and if you think about it, this is what you can do too. You guys have seen this notation before when you've been in algebra. Can you write this over 5? Can you reduce that? Yeah. Do you have all whole numbers and no denominator when you do that? Yeah, it works, right? So this works, yes. Because 5 is a factor of 2 times 3 times 5 times 7. It's in there, it's listed. How about the next one, part E then? No. What's going to happen when I have that plus 1? Yeah, whatever that number was before, and it may have been even before though. Right? Whatever that number was before, you know it ended in a 5 or a 0, right? What happens when you add a 1 to it? Now it's going to end in either a 1 or a 6. And if it ends in a 1 or 6, no good. Alright. So no, because this will now end in 1 or 6. Alright, we'll stop there today.